A particle's velocity is described by v of x is equal to bt squared, where b is a constant and t is in seconds. At the initial time is 0 seconds, the initial position is minus 20 meters, the final time is 5 seconds, and the final position is 15 meters. What is the value of b? So we know that the function for velocity is bt squared. We also know that the velocity is the derivative of the position with respect to time. So we can just simply set these two equal. And then here you get a differential equation that you can solve. You can just use separation of variables and multiply both sides by dt. And then now we can just integrate both sides. So we can say that the integral from the initial position to the final position with respect to x is equal to the integral from the initial time to the final time of bt squared with respect to t. Now b is a constant, so we can just move it in front of the integral. And as for the left side, this is just really simple. It's just the final position minus the initial position, because this just means you're integrating 1 with respect to x, and that's just x. And then you just plug in these two. So x1 minus x0. Then you're going to set this equal to the other integral. And then now you can just use the power rule to solve that one. And we're plugging it in from the initial time to the final time. So that is just simply simplifies to the final position minus the initial position. And we're going to set that equal to 1/3 of b times the final time cubed minus the initial time cubed. And then we can just plug our values in. So the final value of x is 15. And then the initial value of x is minus 20. Then we're going to set that equal to 1/3 b times the final time cubed, so 5 cubed minus 0 cubed. And now we just solve for b. So this just evaluates to 15 plus 20. So 35 equal to 1/3 b times 125. And then if you just solve this equation, you should get that b is equal to 0.84. And that is your answer.